Hello everyone. Today we are going to study about indexing and slicing. So with the help of the pandas, we can perform many functions on our dataset like slicing and indexing. So first let us understand what is slicing is with the help of an example by using .iloc function. So as usual, first we will import pandas and we're going to alias it as pd. Enter. Now let me copy and paste some dummy data set. Okay, so I just pasted a dummy data set which contains the players' names, their age, regarding their weights and the salary they earn. Okay, now I press Shift plus Enter. And yeah, as you can see, it has changed into a data set, data frame, where we have index 0, 1, 2, 3, 4, 5, 6, and we have column name, age, weight, and salary. Now the first operations we are going to do is slicing the rows in this particular data frame using the .iloc function. So when it comes to selecting rows and columns of a pandas data frame, .iloc function is majorly used. And what does this function mainly does is like it selects rows and columns at specific integer position. So you need to pass in the values regarding the position or like using the integer index values and the column position in numeric form, so it will fetch you the results accordingly. So let's see through an example. So this is our data frame. Now I will use df1 equals to df.iloc, and in this parameters I want to slice up my data frame only for the top 4 rows. So I will put 0 colon 4, and also I need to print it. So again, Shift plus Enter. Okay, so as you can see, it has fetched me the top 4 rows. When I pass 0 to 4, so it tells that fetch from 0 to till 4th row, but exactly not the 4th row. Actually, it fetches 4 minus 1, that is a 3rd row, if you include 0 as your first row. So it will fetch you the results, the top 4 rows from your data frame. That means we have sliced our data set based on the rows. Now, if you want to slice up your data set via the column format, so you have to do 2 equals to again df.iloc. I want to fetch all the rows, but 0 to second 2 minus 1 column. Print it. Now as you can see, first column I haven't passed anything, so only just a colon, so it will fetch all the rows, that is in our data set all the 6 rows. But on the column side, we only need to fetch only the first 2 columns. That's why we have passed 0 to till 2. So it has fetched name and age column with all the rows, as we have passed nothing. So it has fetched all the rows. So this is what slicing is in pandas data frame. There is an alternative form to this .iloc function, which is the loc function. And the difference between these two functions is basically that loc will select rows and columns with specific labels, while iloc that we have currently used selects rows and columns at specific integer positions. And this is what slicing operation is. You can either slice your data frame in row manner or in column wise. So these are the two important ways in which you can slice your data set. Now next operation which we are going to see here is indexing. So for indexing also we're going to make use of the same data set which we are working till now. And we will just make a slight change to that particular code. So let me just copy paste it. So in this piece of code I'm just going to add an additional parameter which is index. So I will pass capital A, B, C, D, and parenthesis E, F, capital F, comma, capital G. Now let's run this piece of code. Now as you can see, instead of 0, 1, 2, 3, 4, 5, which we used to see till now, has been updated to new value, which is A, B, C, D, E, F, G. This is what an indexing argument does. It just indexes your columns with the respective values which you can pass it in the index argument. Okay, so this was it about indexing and slicing. Next, we will study about some basic data manipulation techniques, and we are going to perform some basic operations on our data set. And let's see about it now. So the first operation which we are going to look is to if you want to add a new column to this our data set. So in order to add a new column, suppose I want to add number of wickets taken by these players. I know that these are the batsmen, but I wish to add a column which says how many wickets each player has took. So in order to add that column, what I can do is I can just type df, and in square brackets I will just give it a name. So I will type wickets, and I'll put equal sign, and again now I will pass on the values. So I'll take arbitrary values 10, 23, 13, 14, 25, 30, 1, 2, 3, 4, 5, 6, and we have total 6 values. Now if I press enter, okay, it says length of value 6 does not match. Oh, I passed one value less. Need to add one more. Now I press enter. Okay, now I print df. So as you can see that wickets column has been added. So what this df wickets does is it will search the column, and if it doesn't find any column named wickets, it will create one, and the values which we have given here, it will just assign those values to the same index position accordingly. Like 10 is given to the first index position, second index position 23, third index position 13. So 0, 1, 2, 3, 4, 5, 6, and so on it will do. And one more operation is in order to fetch the top 5 rows, we can even use .head function and enter. It will bring you the top 5 rows of your data set. In order to get any number of rows you want, you can specify that number inside this argument. If you want to get only the 3 rows, so you can pass 3 and press enter. So this works like this. Okay. Now next, the operation that we are going to look is deleting a column. So the best way to delete Dataframe column in Pandas is with the Dataframe.drop method. The drop method is very flexible and can be used to drop specific rows or columns. It can also drop multiple columns at a time by either the column's index or the column's name. There are 7 possible parameters you can pass to drop method, but only the 2 methods are required. That is, without those 2 methods you cannot run that particular function. That is, those 2 arguments are compulsory. So let's look 3 of them. 3 out of 7, let's look them. So one is label, so which says the index or column labels to drop, whichever column you want to drop, so you can pass on their labels. So axis, another is axis, whether to drop labels from the index 0 to index or columns 1 to the column name, which you can specify. And another is in place. So if you specify it as true, so it will complete the operation and it in place, and it will return none, and it will definitely change the data set itself. And if you specify false, it will create a copy of it and it will perform the operation on that, leaving undisturbed the real data set. So now I wish to drop this wickets column. So what I will do is df.drop, and in this I will pass the column name, that is wickets, comma, I want to delete it via the column wise because I want to delete the column. So I will specify 1 as passing 1 will delete the entire column. And in place I will pass it as true. Now after typing in place equals to 2, it will delete from the existing data set, so it won't create any copy. Now if I print it and run this, you can see the wickets column has been deleted. You can even delete multiple columns. You only need to give the range, like instead of wickets you can type df.columns, and in the square brackets you can type on their index values. Like if you want to delete name and age, so you can pass 0 and 1, so both these columns will also get deleted. And another thing which you have to make sure is to pass 1, as you have to delete column wise as we are performing it, the operations on the columns. Now the next operation which we are going to see is to rename a column. So in renaming a column, the simplest ways to achieve this in Pandas is to just use dataframe.rename method. This method has 8 possible parameters that you can pass, but for basic situations you can get by with only the following 2 parameters. That is, one is columns and in place. The columns is basically the dictionary like transformation to apply to the column labels, and in place is again that whether the operation you want to do is in place, and if you pass true, so it will do the operation in place, that it will make changes in the original data itself and it will return none. So let's rename the salary column to earnings column and see how it is done. I will write df.rename columns equals to, I have to put curly braces, like I have to specify which column I am renaming. So I am renaming salary column, and I have to put column to the new name. So new name I am going to write it as earnings, and again after this comma in place, that is I want to make changes to the original data itself. I will pass that true. I will print the data set. Oh, I forgot to close the bracket. Okay, now let's run it again. Oh, I have to delete it from here. Okay, now as you can see, our salary column name has been changed to earnings. The next operation which we are going to see is to just sort the columns. So in order to sort the column, we can make use of the df.sort_values function, and in the argument we can pass on the columns names, like through which we want to sort our data. So suppose I want to sort the data based on the age, so I will use df.sort_values, and in the parameter I'll pass by equals to square bracket. I want to specify age. So you can see I have sorted the age column in the descending. By default it takes descending, I mean ascending. So in order to get into descending, you have to pass ascending equals to false. If you don't pass anything, it will sort it in ascending manner. The next operation which we are about to see is binning. So basically binning is also known as bucketing or discretization. So which is a common data pre-processing technique used to group intervals of continuous data into bins or buckets. So basically if you have continuous data and you want to group those data into one frequently 2 to 3, 4 categories, so you can make use of binning. So let's see an example over here. So consider this. If we are having a weight column and I want to categorize this into basically 3 categories, which is lightweight, weighted and super weighted. And the condition will be that if a player's weight range from 0 to 75, I will consider it or label it as lightweight. And if a player weight ranges from 75 to 85, I will count it as weighted. And a player who has a weight above 85 to 100 will be labeled as super weighted. So in order to achieve this, first we need to create bins. And before bins, we need to understand the function that we'll be using. We will make use of the cut function. So it will bin the values into discrete intervals. And this function is also useful for going from a continuous variable to a categorical variable. And this function also takes many parameters into consideration. First is take the input array to be binned, and it must be one dimensional. Second, bins, which is sequence of scalars which defines the bin edges allowing for non-uniform width. Another is labels, which specify the labels for returned bins like superweight, weighted and lightweight. And it must be of same length as the resulting bins. And also final is include underscore lowest, which is a Boolean value, which considers whether the first interval should be left inclusive or not. Now let's code it. First we will define bins. Now I'm going to take range from 0 till 75, 75 to 85 and 85 to 101. Let's take one extra value. Now labels. Now since we have part 4 ranges, so accordingly we need to have 3 labels as well. So first label will be lightweight, second will be weighted, third will be super. Okay, now let's create a new column in our dataset. We will name it as weight category. And now we'll make use of cut function. So pd.cut, and inside we're going to pass x equals to the column which we are going to perform operation on, so which is weight. So df weight comma bins equal to bins that we defined earlier, labels equal to labels, labels, comma, and include underscore lowest set to tr. After that, we print our data set. Oh, again, I think this mistake of square bracket here, and remove this. Also, okay. Now, as you can see, based on the weight value, the bin category has been assigned to respective player's weight. So MS Dhoni is weight 75, it is lightweight, 74 lightweight, 80 in the range of 75 to 85, 100 risky, and this is how pinning works. So these are the important operations. We will learn some more operations in the next video, as this video is getting a little bit long. So yeah, let's discover some more operations in the next video.